Welcome to the university and welcome to this event organised by the Sustainable Consumption Institute. My name's Rod Coombs, I'm Deputy Vice-Chancellor and chairing this event today. But I should say straight away I'll take off my Deputy VC hat and wear my SCI hat because I was for a while in the early years of the SCI involved in managing some aspects of the Institute's work and have kept a close involvement with the SCI since then as the chair of its Strategic Management Board, which involves representatives from the university and from the principal funder of the Institute, Tesco plc. Just a few words first of all about the Institute for those of you who are not familiar with its broader portfolio of work before we focus in on the research that we're going to be discussing in detail today. It was established in late 2008 with primary funding of £25 million from Tesco plc. Since then, we've worked extensively on many different research areas. Actually, a proportion of it with Tesco, but maybe at least half of it with other collaborators and other funders from other private and public sector organisations. So we have research money from many of the research councils, from EPSRC, from ESRC, from the European Union, and from other private and not-for-profit organisations outside the public sector as well. The portfolio of research of the SCI is very broad. But during my time as acting director about 3.5 years ago, we put in place three very large flagship projects of the SCI's work, one of which we're going to hear about at this event, led by Dr. Alice Bowes, who will speak in a moment. But I thought just for giving you a perspective on the breadth of the SCI's work, I'd just quickly in one sentence encapsulate the thrust of the other two flagship projects, Flagship 1 and Flagship 2. Flagship 1, which is led by Professor Dale Southerton, is really focused on consumption itself as a set of practices. And really what it's concerned with is, and I've summarised this in my words, Dale might express it slightly differently, but to me what Flagship 1 is about is analysing how the segmentation of households and tastes interacts dynamically with the actual array of products and services that we have and the way people perceive the carbon content of those products and services and their actual carbon content. So it's really a project with a sociological focus using raw primary data from sources such as Tesco's Club Card, as well as new theoretical models drawn from sociology and economics to ask the question, how do people perceive carbon-sparing products and services in their everyday lives? And what's the interaction between their everyday practices and their use or non-use of those carbon-sparing products or services? The second flagship project, which is led by Professor Andy McMeekin, is concerned with innovations in products and services that reduce their carbon intensity, but particularly how that innovation process is distributed up and down the supply chains which generate those products and services, and looking at the interaction between the commercial, the technical and the policy and regulatory issues which drive the points of innovation within supply chains that either do or do not reduce the carbon intensity of products and services. And then the third flagship project, which we're now going to look at, led by Alice, I won't try to encapsulate quite so directly because I might get it wrong and she might tell me off. So I'll let her talk about that. But as I see it, it's really about looking at emissions mapping and trying to relax some of the very simplistic constraints on early work on emissions mapping and reintroduce some of the complexity that we know is there, and look at the way that creates, if you like, different levels of contingency and uncertainty around things like 2-degree scenarios and 4-degree scenarios for climate change. And then focus in on, for today's work at least, on the way that impacts on our understanding of not just food supply, but what we might loosely call food behaviours and the interaction between the two. I'll get told later on whether I've got that right or not. So that's the positioning of today's piece of work in the broader SCI portfolio. I hope that's useful. And I'll now, without more ado, hand over to Alice and her two colleagues, who, as you will have seen from the agenda, are going to present different components of their research results for the next, well, from now until about 11 o'clock. So over to you, Alice.
Okay, thank you very much, everybody, for coming to this launch of our new report called What's Cooking. My presentation is just going to give you a bit of a flavour of the framing of the actual work, with a couple of some key messages and some key results. And it focuses primarily on the physical science side, because that's my particular interest as a researcher. But the work has also been done by Ruth Wood and Ellie Dawkins, and also, I should say, John Barrett, who's also here, participated and helped lead this part of the work at the beginning of the project as well. So our research project aim originally was to develop consumption scenarios that capture futures that are changed by both adaptation to climate change and by mitigation. And there are many questions that helps us to bring up, to kind of explore. But some of the key questions that we focused in on were, what difference does it make to food supply chains if the climate changes by different amounts? What changes may be needed for both the energy and the food systems under high and low mitigation futures? And how might these different futures materialise? So what policies, what infrastructure needs to change? What do we need to do differently in the near term in order to bring about very different futures by 2050? The process that we've gone through is to develop a suite of food system scenarios, and that process was a participatory stakeholder engagement process. So there were many people that we involved within our workshops during the course of the last 2 years. And one of the key messages that we discussed with our stakeholders was the idea of influencing the future. We know that by its very nature, anthropogenic climate change is because people have done things in a particular way and therefore have influenced the climate. So the point is that we do have an influence on our future, and that is going to continue. So the decisions that we make now in relation to energy policy and food policy and so on are going to have an impact on the amount of future adaptation that we have to face. So we can either mitigate a lot, higher mitigation, which means that we will have to adapt less, or we can mitigate less, which means that we're going to have to adapt more. So there isn't, just one choice out there. There are a number of choices. But what we don't have in front of us is a choice of a no climate change future. We will have some climate change. We're already seeing climate change. So a no climate change future is not an option. But there are different levels that may materialise because of the decisions that we make now. Now, we're probably all familiar with a 2-degree warming above pre-industrial temperatures. This is the level that is considered to be dangerous interference with the climate system, and the level that governments around the world have signed up to, committed to, under the Copenhagen Accord. Why are we trying to avoid this? Well, it has a number of serious impacts that are considered to be dangerous, such as 20 to 30% of species at increased risk of extinction, widespread mortality of corals, increased risks of extreme weather events, increased water stress, wildfire frequency and floods, hundreds of millions of people suffering coastal flooding. And there's also this issue of tipping points. So many of the climate scientists think that at around 2 degrees, we might end up increasing the chance of some positive feedbacks that could tip the climate system into a new state. But 2 degrees isn't the only future that we're facing. And in fact, we're probably, well, very likely not on a path towards 2 degrees at the moment. So 4 degrees is another option that is perfectly within the bounds of possibility that we may be facing. So what's the difference between 2 degrees and 4 degrees in terms of the kinds of impacts that we might face? And this is just some work just very briefly taken from the Hadley Centre and the Foreign and Commonwealth Office, who've looked at what some of the impacts around the world might be at 4 degrees. So for example, if you look at the hottest days that we currently experience, well, we're looking at 8 degrees warmer for places within Europe on the hottest day, so on top of the hottest day that you might have in a heat wave already, and 10 to 12 degrees hotter in places like New York and Chicago. And there are obviously devastating impacts for many aspects of the system, but food crops in particular, obviously relevant to this project. At 4 degrees, we're looking at a 40% reduction in the maize and wheat yields in low latitudes, and a 30% decrease in rice yields. And this is in areas where there may be there will be a growing demand for food. Obviously, there are issues of equity and redistribution there, but these are places where the demand is growing, and yet the actual impact on these yields is going to be devastating under 4 degrees. So then the question is, well, how do you link these different futures, 2 degrees or 4 degrees, back to policy so that we can think about what needs to change in the near to medium term? And our research is all framed around this issue of cumulative emissions. So this graph here is the emissions up the left-hand side from the year 2000 out to 2050 along the bottom. And this is just to illustrate that it is irrelevant, essentially, where we get to by 2050 in terms of the level of emissions, because it's actually the area under this curve that really matters. So the grey area here indicates the amount of greenhouse gas emissions that have already been released. We can't do anything about that. But one of the things that if we were trying to actually keep to our pathway, if that was our emission pathway to avoid something like a 2 degrees of warming, and if we don't manage to get our policies in place and actually making the emissions reduce in the near term, and we start to overshoot this pathway, whatever we overshoot it by in terms of the area under the curve has to be compensated for in later years. And there are a couple of implications for policy from that particular framing of the research. So first of all, our 2050 target, if we have one, so at the moment the UK has an 80% carbon reduction target by 2050 that it's trying to aim for. That target will shift if we don't do well enough in the near term to cut emissions. It could be 90%, it could be 100% for the same climate impact. The other implication is that the trajectory will become steeper. So if your organisation or business or your university and so on is trying to cut its emissions by a certain amount each year, say 3% on an annual basis, then if we don't do enough in the short to medium term in terms of cumulative emissions, then those emission reductions need to be more stringent. So we need to look at 6, 7, 8% per year cuts if we don't do well enough in the short term for the same climate impact. Obviously, the other alternative is that the impact on climate change is greater. So that means that we can actually contrast these 2 degree and 4 degree futures, even if those temperatures don't materialise till much later in the century, because it's actually the near term and the near to medium term emissions that really matter. So it all points to what we do in the short term. And this graph here got greenhouse gas emissions up the left-hand side, 1990 out to 2100 along the bottom. And these are two pathways, one for 2 degrees, the green one, and one for 4 degrees. And you can see that because the cumulative emissions matter, very soon in the near term, we need to change the trajectory. We need to get off more like a 4 degree type pathway and get onto the 2 degree pathway. And that means that we need to do things now. So where is current policy leading? Well, global emissions are continuing to grow exponentially. UK policies are not delivering in line with 2 degrees. That's not to say that the UK isn't doing a lot in relation to climate change. It's certainly got a Climate Change Act. It's thought to be world leading in terms of its policy. However, its carbon budgets that the UK has are actually premised on the likes of China and India having a peak in their emissions in the very near term, which is really unrealistic. So we're on a low mitigation, high adaptation pathway at the moment, facing something more like 4 degrees by 2100, and some analyses actually suggest that those 4 degrees could be by as early as 2060, and I know that the International Energy Association are actually talking about maybe we're facing 6 degrees on the business as usual trajectory that we're currently on by toward the end of the next century. So if we want to tackle this, we need to think about, well, what's making up these cumulative emissions and what can we do about it? Well, on a global scale annually, the majority of these emissions are CO2 emissions associated with energy and industry. About 12% are from deforestation, another 22% from the other non-CO2 greenhouse gas emissions, and it's those that I just want to focus in on a little bit now. Another graph, similar thing, greenhouse gas emissions up the left-hand side, time along the bottom. Now this is a pathway that's taken from a paper that we had published in 2009, looking at a typical pathway to avoid a reasonable chance of avoiding 2 degrees. This bit here are the historical emissions. This blip is due to the recession, so emissions did dip slightly and then started to rise again. And then this area under this curve here actually shows us the budget that we've got available for all of our greenhouse gases for a certain level of climate change, for a 2 degree of climate change. So that's the space for all of the gases. But within that, we have these gases, these non-CO2 greenhouse gases, primarily nitrous oxide and methane emissions. And at the moment, the split between those, this is kind of the current data, is about 34% and about 61% in terms of the methane emissions, and a small amount made up of other gases. 60% of those are actually from agriculture. Now, we have policies and we have technologies that can address some of these emissions, particularly in relation to energy and waste and industry. But the agricultural emissions are much more challenging, and Miriam is going to talk more about this shortly. But one of the issues is a rising demand for food. Others are the use of fertiliser, and also how you can capture or you can reduce the emissions produced by livestock and also by paddy rice fields. So there are some really big challenges there in relation to agriculture. But if this is our limited carbon budget, and we know that we've got certain emissions from agriculture, from these non-CO2 greenhouse gases, then they're going to take up a portion of our budget in the future. And if we manage to do something significant about energy, then they could make up the majority of our carbon budget by 2060 or so, probably in a 60-40 split between nitrous oxide and methane. Now, the argument we're trying to make here is that the importance of these non-CO2 emissions is often overlooked, and therefore we tend to focus a lot more on the CO2 emissions associated with energy. But if we can't reduce these non-CO2 emissions as much as we thought we could, or we're not actually addressing the technologies that we really need to drive those down, then that means that we have to do more on the CO2 from energy for the same climate impact. So it means that there are implications for our energy scenarios and for our energy policies. So some of the lessons that we've learned from focusing on agriculture and food, from trying to kind of look a bit more closely at that rather than at the energy system, which a lot of us who are researching this are a lot more familiar with, it has to be said. One of the things is how deeply you cut your food emission actually is going to dictate what you have to do on your energy-related CO2 emissions or on your climate impacts if you haven't addressed those properly. Other specific issues, agriculture is going to be severely affected by climate impacts, and again, Miriam is going to talk about that shortly. But in essence, as temperatures rise, it may be that it gets increasingly difficult to actually reduce the emissions from agriculture. And actually, in some parts of the world, the agricultural emissions will rise to produce the same yields because of the climate stresses. I pointed out that we need to do something about these short-term emission pathways. We need to get off the curve very soon. That points to looking at consumption, because although there may be technologies that can come on stream by 2050 to help us decarbonise, a lot of the time they might be a large-scale infrastructure change which takes many decades to bring about. Whereas if we look at the consumption end of the supply chain, we can tackle emissions in the short to medium term. That's not to say that changing behaviour and changing consumption is going to be easy, but from a physical science point of view, it is actually physically possible to do something about the consumption in the short to medium term. But obviously something we need to explore more. Another important issue when you focus in on food, we've looked at the emissions associated with full supply chains, what's known as the consumption-based emissions, not just the emissions produced in the UK. And that means that your emissions are actually linked to nations that don't have climate change targets, so what we call non-Annex B countries. So they don't have goals under Kyoto and that sort of thing. So our emissions are going to be linked to those countries where there aren't any measures to try to reduce those emissions. And so if we actually want to tackle those supply chain emissions, we have to think about what we do and we don't have influence over. So to explore these issues, we developed our food system scenarios to try to contrast 2-degree futures with 4-degree futures, but from a UK perspective. So we're actually taking a UK consumption perspective, but then looking out towards the global supply chains. You've probably seen in your report we have 5 different food scenarios, and each of them has a name that is actually based on a type of typical meal that you might actually get within that particular scenario. So it just kind of gives you a hint of the scenario, but without trying to kind of influence your views about the scenario in any particular way. Try to keep them as neutral as possible. So we have 2-degree scenarios, bubble and squeak, and mash and banger, not banger and mash. And then 3 4-degree scenarios, pasta and pesto, chicken tikka masala, and lab chops. And just a few interesting results. Some of these graphs, all these graphs will be in the report that you have. So in terms of greenhouse gas emissions, so greenhouse gas emissions at the left-hand side, we used a baseline year of 2004, and then through the modelling work that Ruth and Ellie have done in particular, we looked at how the emissions play out under our different scenarios. So we have 2 2-degree scenarios, 2 and 3 4-degree scenarios, and obviously the 2-degree scenarios have lower emissions than 4 degrees. But because of this linked to the imports, we actually couldn't reduce the emissions down to a level that would give us a high probability of avoiding 2 degrees. So these have still got more emissions than we need to avoid 2 degrees. And this is simply because of this link to the imports, and also because of some of these food-related emissions. Another thing that we found is that the non-CO2 emissions as a proportion of the overall cross-economy system emissions are actually a greater proportion the harder you try to tackle climate change, and that's because they are more difficult to reduce, and we did quite a lot of work trying to reduce them by looking at different technologies and measures and so on. If we then focus in on the food-related emissions, what you don't see now is that the 2-degree ones are all that lower than the 3-4 degree scenario. So bubble and squeak and chicken tikka masala have similar emissions here. And one of the things that's going on here is that the food emissions are much more influenced by the climate impacts and the technologies that are used to address those climate impacts, as well as the mitigation side of things. So they're less influenced by the underlying decarbonisation of energy, whereas other sectors in the economy are influenced a lot more by energy. So as the conclusions, for a full picture of what's going on in terms of our emission targets, we have to quantify the implications of adaptation on the levels of emissions. So we have to think about what climate change is doing if we're going to really understand how much we can cut our emissions by, and Miriam is going to talk about this more shortly just after me. How deeply we cut these food emissions actually is going to dictate to us what we need to do in terms of energy. So we have to take those into account if we're going to work out how severely energy emissions need to be cut for a certain climate impact. Or we're going to have to accept the fact that we were going to have a more of a climate impact, certainly than 2 degrees. The links to supply chains, which is particularly novel in this work, highlights the importance of emissions associated with imports and means that the picture is even more tricky to tackle than it looks if you only look at the UK's emissions that are produced within its borders. 4 degrees, it was still difficult to avoid. So to mitigate emissions to a level that avoids a 4 degree of warming was still challenging. That is not business as usual. And finally, if we actually want to look at 2 degrees, we really need to look at changes to the levels of consumption and the types of consumption, because we can't get the emissions down low enough just through the technology. Thank you.
Thanks, Alice.